So in the fourth unit, we will be dealing with the next topic, that is the implementation of IIR filters or IIR systems. So IIR systems, we have gone through different methods. By that, we can realize the IIR systems. So the first method that we have gone through is the direct form structure, and here it was 1 and 2. There are two types. The second one was the cascade. The third one was parallel, and the fourth we will be seeing is the ladder structure. Okay, so these are the realization methods. Basically for IIR systems. So first of all, we are seeing the IIR system realization, and then in the second part we will be seeing the FIR system realization. So in the previous class, cascade and parallel realization we have seen. So now there is a question. We will see a question. So here a transfer function is given. H of z is equals to this transfer function, and we need to realize the given h of z into the cascade form first, and then the parallel form. Okay. So we will see one by one. So in the cascade form, what is the method we should be proceeding with? So in cascade form, whatever h of z is given, we will be writing it as h1 of z into h2 of z into h3 of z and so on. Okay. For the realization, always whatever transfer function is there, suppose this is the transfer function, this is the complete numerator and this is the denominator. So this 5 will be your gain. Okay, so that will be gain multiplied by this. So gain, and suppose h1 is there, h1z we need to find out. So two functions, either one of the numerator and one of the denominator, we can combine to form h1 of z. Okay, so any of the factor, whatever is this is the one factor, this is the second, and this is the third, and similarly here in the denominator, this is the first, second, and this is the complete third, and this is the fourth. Okay, so what we can do is we can select any pair. Okay, we can select either one numerator, one denominator. Okay, and that combination will be forming either one transfer function, then similarly h2 object we can see like that. Okay, so this is how the realizations will be taking place. So in the cascade one, and once whatever h1 of z we have seen, we will be making it as in the form of direct form to realization. Okay, so this whatever h1z we have selected, that will be realized in the form of direct form 2, and all other this will be again realized by direct form 2, and all are just cascaded. So suppose this is h1z and another one is h2z, h3z, and so on. So this complete will be your cascaded form of h of z. Okay, so same we can do. This is the generalized, or you can say the simplest method. Okay, so here in this case we will be grouping the poles and zeros of the systems in several possible ways. So there are different ways. So either suppose this way, and this one we can select, or some may have been selecting it this one and this one as h1z. Okay, so there are different possible solutions. Okay, this realization will not be having a unique solution. It will not be having. Okay, so it is not giving you out a unique solution based on the preference, whatever numerator and denominator poles or zeros you have selected. You can have different realizations. Okay, so one of the possible ways is given here. So in that, it has selected h1z is equals to, so for h1z it has selected 2 minus sorry, 1 minus 2 by 3 z inverse. So this term along with this term, and then the term that is realized is the denominator term. Okay, so these two terms they have multiplied. After multiplying this will be given, and the remaining part is this term and 5. Okay, so 5 has taken outside, so 5 taken outside. So this first term in the numerator and second term they are multiplied. Okay, and after multiplying, the term that will be getting is this one as the numerator, and this one after multiplying we will be getting this. Okay, so either you can have only h1 and h2, or we can have h1 h2 h3 h4. Okay, based on your preference you can do that. So here it is in the form of 1 by 2 j in the form of poles. Okay, so after multiplying this we will be getting this as the representation. So this is second order system. So second order system can be realized directly by using direct form 2 structure. Okay, so after combining it will be easy. This is first form, or you can say first. So once it is having a poles that is existing in the complex conjugate pair. So always imaginary poles are exist in uh, a pair. So this will be multiplied and we will see the simplified version. So this is the simplified version of the second order equation. So this second order equation can directly be realized. Okay, so and at the numerator part, this term and this term, these two are multiplied, this will be getting. Okay, so here it has selected only two multiplication terms, two, or you can say two transfer functions as the multiplication to get the h of z. Okay, based on your preference you can either select only two, or you can make this transfer function to be more simplified in the form of first order systems only. So that will be four type. Okay, first, second, third, four different transfer functions can be obtained, and we can multiply that, and after multiplication we can get the h of z, final h of z. Okay, so if we have considered h1z and h2z such that, okay, then at that time h of z will be given by 5 into h1z into h2z. Okay, so now from there, if h1z is there, okay, so we will be realizing h1z in the form of direct form 2, and then h2z in direct form 2 separately, and then we will be combining it to find the uh, h of z realization in the cascade form. Okay, so it has gone through the equation by expanding this h1z. It has written as y1z divided by your x1z, and similarly h2z it has written like y2z divided by x2. So once we will be simplifying it in terms of time domain function, it will be giving out this expression. Okay, so from this given expression you can directly implement, or you already know like how to represent, how to realize a given transfer function into the second order system. Okay, so we will directly can do that. So first of all, like this is zeros. Okay, so this is the representation in the form of zeros. So in the direct form 2 structure, the poles are represented on the left hand side, or the first, the poles we will be representing the first, and the delay elements. To realize the numerator part, only one delay element is required. To realize the denominator part, two delay elements are required. So one will be shared with the other one. Okay, so one will be shared and one gets the gray one. So to realize the poles, after first delay element, okay,
Damn, man.
after the so after the first one, so this is 1 minus and this is plus. So if it is minus, it will be positive coefficients. Here it is plus, then it will be a negative coefficient. Okay, so here relation will be a positive coefficient, and here it will be a negative coefficient. Okay, and similarly to realize the zeros, we will be having a coefficient that is given already. So the coefficient given is minus 2 by 3. So minus 2 by 3 that directly multiplied after one delay, and we will be getting this. Okay, so this is your, this is the realization for the h1. This is h1z realization. Okay, similarly we will again go for H2Z realization. So in the H2Z realization, this numerator is also second order and this is also the second order. So once we are having the same order, then the number of delay elements will be up maximally, you can say, utilized. Okay, so we can have it, two delay elements will be required, and here it will be poles representation, and these are the zeros representation. Okay, so for poles, uh, it is 1 minus, so 1 minus coefficient of j to the power minus 1 is 1, so 1 will the coefficients here. Okay, so in this is the one coefficient will be there, so here plus is there, plus 1 by 2 is there, so in the coefficient part it will be minus 1 by 2 will be taken, so minus 1 by 2 will be taken. Okay, so similarly in the zeros representation, what are coefficients are there, if it is positive, positive will be there, if it is negative, negative will be there. So this is how the h2 of z will be represented. So h1 of z into h2 of z, and 5 is remaining, so here a 5 coefficient is directly multiplied, so this 5 coefficient can be multiplied at the end, or we can multiply at the starting also. Okay, so either of these two can be utilized, uh, either at the end or at the starting. Okay, so this is how the realization of h of z will be taking place. So 5 into h1 into h2, that will be your h of z. Okay, so this is your cascade realization. Similarly, we can do the parallel realization. So in the parallel realization, what we need to do is we need to do the partial fraction. Okay. So in the partial fraction, to realize the partial fraction, what we do is whatever uh, h of z is given, we will be considering h of z divided by z, and we will be doing the partial fraction. And after doing the partial fraction, we will be finding h of z by multiplying this term. Okay, once we have find out the h of z, we can realize it individually. Okay, so whatever realization will be there, so this will be in parallel from this one, and single input will be there, and different realizations will be there, and at the end all are added. Okay. So this will be the realization x of n and y of n. This is how the parallel realization is taking place. Okay, so for the parallel realization, we will be expanding it. So here in the question part, it is separately already given it is, and the given system will always be making sure like where it is given in the terms of uh, j to the power minus 1, or we can say the first order system. By making it first order system, we can separate it. So this will be a separate term, this will be separate term. It is already given in this fraction form or factorized form, so we can separate this one and this one. So four different denominator parts will be there. Okay, so this is your first one, second one, and third one, and fourth one. So whatever coefficient will be there here, the same complex conjugate coefficient will be here, because these two are almost same, only the difference is their poles, that is complex conjugate. We can directly write it in terms of we have written this like this term, individual terms, or we can combinedly write the second order term, 1 minus z inverse plus 1 by 2 z to the power minus 2, then the coefficient will be a constant plus constant into z to the power minus 1, that will be the coefficient. Okay, so we can do whatever way you like. Okay, so final our motive is to find out the uh, final motive is to find out the partial fraction. Okay, so after finding the partial fraction, once you have found out the partial fraction, we will be proceeding with the coefficient finding. Okay, so these coefficients can be found. So after finding the coefficients, once we have found the coefficient, we can directly write it here. So h of z will be represented as this after writing the coefficients. Once we have written the coefficients, we can individually make sure. Okay, we can individually write this, or what we can do is we can combine two. Okay, so two factor terms we have combined and make sure like it is second order system. So once it is second order system, you can reduce the number of or you can say it will be easy to design or realize the second order system. So we'll be combining it, or we can individually do also, but these two should be combined because it is an imaginary form. So this to realize imaginary form, it is difficult. We cannot realize imaginary form into the physical world. Okay, so we have to combine it and do your direct form second realize. So after combining these two, this will be obtained and coefficients will be combined. So this is the second order system. So the poles will be realized first. So here it is minus and this is plus. So it is minus, it will be positive coefficient. If it is positive, here negative coefficient will be 3 by 32 and two delay elements will be there. After first delay element, the coefficient, this will be realization of zeros. So in here the zeros are like the first term into 1 plus 1.846. So 1.846 is the coefficients, and here negative is there, so negative will be multiplied here. Okay, so this is the realization of the first term, like it is written in the terms of h1z plus h2z. So this is your h of z. So in parallel form, the h of z will break into h1z plus h2z form. But in case of cascade one, it is break into h1z into h2z. Okay, so if it is n2, it will be the cascade form. If it is plus, it will be in parallel form. So the first term will be represented. After that, the parallel representation of the second term will be there. So we will be realizing this term. So it is also second term, second order system. So two delay elements will be required. So the first coefficient point is -1. So it will be -1. So if it is -1, it will be here plus. Okay. So if it is plus here, if it is here plus, it will be minus here, -1/2. And similarly in the zero side, this is for the poles and this is for the zeros. So in the zero side, the constant is 5.02, and the z to the power -1, the coefficient of z to the power -1 is this one. So after this is z to the power -1, so this will be your z to the power -1 point. Okay. So okay, so this is how the realization will be taken. So once we have gone through, that will be realized. Up to here, I think you might not have been any questions. Okay. It is very easy to realize the parallel and cascade form. Even if you have any doubt, you can ask. Uh, Otherwise, we will be proceeding with the second topic. So the topic is a ladder structure. So till now we have seen direct form, cascade, and parallel. The fourth one is ladder. Okay. So in the fourth one, the ladder structure. So as the name is suggesting, ladder means that is drawn like a stair one by one. So first one is there, then second will be realized, then third will be realized, fourth. Okay. So this is like a ladder. Okay. This is the realization of a ladder structure. So that's why it is called the ladder structure. So we will see like what given transfer function is given there. Okay. So based on the transfer function, we will be dividing the transfer function such that it is represented in this form. Okay. So here h of z is given, that is generalized form. So in that h of z, that is having an order system, and this is also an order system. Okay. So into that we will be dividing this complete to this one, whatever is obtained, then we will be again dividing that in terms of uh, second form. So just that how the coefficients are being calculated, that we will be seeing. So whatever system is there, suppose that is 1 plus 2 z inverse plus 3, sorry, so it is 1 plus 2 z inverse plus 3 z inverse 2. Okay, so 1 plus 5 z inverse plus 4. So this is how. So what we do is we will be dividing this numerator by this denominator. So whatever coefficients will be there, that will be coming out to be in terms of a constant. Okay, and then 1 by this form. Okay, similarly we will be keep on breaking. So these two terms are like alpha naught plus whatever is there plus 1 by beta 1 z to the power -1 form, and then again whatever transfer function will be there, that will be of the form same h of z. So here it will be again break into alpha 1. If it is alpha 0, so second only alpha 1. Then if it is beta 1, it will be beta 2 z to the power minus 1. Okay, we will keep on breaking it such that at the last we are having no z to the power minus 1 term. Okay, or we will be having a constant value. So we will see with respect to the example, it will be clear like how we are going to break this h of z into the ladder structure. So there are different methods. So one of the method is, so this realization will be done once we have the value of alpha 0, beta 1, alpha 1, beta 2, and keep on different values once we have calculated. So this is the first one, this is the second pair, similarly the third pair. Okay, so alpha beta pairs will be we need to find out. So this, to find out these values, we will be using method called route array. So route array is like route Hurwitz method is there, through which we can find out these alpha and beta coefficients. So the method to find the coefficients is, so whatever transfer function we have given in the numerator and denominator. Okay, so in the numerator it is having z to the power minus n. So we will be writing z to the power, what is the highest power in the numerator, that is z to the power minus n. Similarly in the denominator, what is the highest power, z to the power minus n is the highest power. And then for the maximum power, 2, 1 less than that, negative 1 less than that, and keep on reducing until there is z to the power 0. It is like z to the power 0. So z to the power 0 for the numerator, and this denominator. This first term is for the numerator. Whatever highest power of z to the power is there in the numerator, similarly the highest power in the denominator. So okay, so that we will be writing. So whatever highest power is there, suppose that is z to the power minus n. So how these values are written? So whatever the coefficient of z to the power minus n is there, that will be written there. Okay, so alpha n is there, alpha n minus 1 is there. So coefficients we will be writing. So alpha n minus 1, and keep on writing. That means highest power of z to the power minus n. What is the coefficient of this z to the power minus n, and then what is the coefficient less than this value, and so on we will be writing. Similarly for the numerator and denominator. So once we have retained the denominator and numerator coefficients, so up to here it will be given into the question, and these are the values we need to find out. Okay, so these values we will be finding out. These are the values we have to find. Okay, so the method that is used to find these values are, so we need to find out Cn. So Cn minus 1 is the value we need to find out. So to find out Cn minus 1, what we need to do is we will be multiplying these two. Okay, okay, so we will be multiplying Bn into this one. So we will be multiplying Bn into alpha n minus 1. Okay, and we will be subtracting the multiplication of these two. So an or alpha n will be multiplied by b n minus 1. Okay, so b n minus 1 is there. So after multiplying these two, we will be subtracting multiplication of these two, and we will be dividing it by bn value. Okay, so this is the Cn minus 1 value. Similarly, to find out Cn minus 2, to find out the Cn minus 1, Cn minus 2, what we need to do is we will be multiplying these two values and multiplying these two values, and after multiplication of these two, we will be subtracting multiplication of these two. So it is bn minus 1 into alpha n minus 2 minus alpha n minus 1 bn minus 2 divided by this bn minus 1. So it will be more clear once we go for the designing with the values. Okay, so it might be seeing you complex, but once you will be proceeding with the numerical, that will be easy. Okay, so not afraid with these equations. These are very simple once we go for the go with the numerical values. Okay, so again, once we have found out this value, again we will be finding all other values up to c0. Similarly, we will be finding d n minus 1 value. Okay, so similarly the d n minus 1 value will be given by, so we need to find out this value. So this value will be whatever is the above value. So these values we have find out by using this formula. So these values are known. So to find out this value d n minus 1, what we need to do is we need to multiply these two and subtract the multiplication of these two. So it is d n minus 1 value will be there, that is c n minus 1 into b n minus 1 is there, minus we will be subtracting b n into c n minus 2, and it will be divided by your c n minus 1 value. Okay, similarly, once we have found out this value, we need to find out the d n minus 1, sorry, n minus 2. So we need to find out d n minus 2. So to find d n minus 2, what we need to do is we need to multiply these two value and we need to subtract these two value. So it will be c n minus 2 into b n minus 2 minus b n minus 1 into c n minus 3 divided by c n minus 2. Okay, so this is how we need to find out these values. So once we have find out all the values, these coefficients, these are the coefficients called coefficients of the different orders of z. Okay, so we can find out this c, d, e, f, g, and at the last up to z to the power 0 values are there. So one will be there. So whatever coefficients will be coming out, we will be finding out. Okay, so once we have found out these values, then into the ladder structure. So whatever structure is there, what is the alpha naught value will be there? We need to find out finally alpha naught, beta 1, alpha 1, beta 2, and similarly alpha 2, beta 3, and keep on finding. Okay, so that values will be directly given by these first column values. So whatever first column values are there, that will be giving you out the alpha 1 and different values. So alpha 0 will be given by the alpha 1 alpha n divided by beta bn. Okay, so alpha 1, or you can say an divided by this bn. So after dividing these two, we will be finding out the alpha 0 value, and after dividing these two, okay, so b1 will be given by bn divided by cn. So it will be b1 value, and we will be dividing these two, we can get alpha 1 value, and so on we will be keep on finding. Okay, so it will be alpha 3, similarly beta 2, sorry, beta 3, alpha 0, sorry, alpha 2 will be here, beta 3, and okay, so on we will be finding out the value. So once we have find out these values, we can directly write uh, this expression, or you can say this structure. So this is your ladder structure. Okay, so this structure we can directly write. So from there we can just realize the ladder structure, and we will be seeing like how this ladder structures will be generated basically. Okay, so in this first form, okay, here, so suppose this is the h of z. Okay, same h of z is given here also, is this expression. So this is h of z is equals to your y of z divided by x of z. So transfer function is given by output divided by input. Okay, that is okay. So from there, what we can do is we can realize this in terms of the first pair. So this we have considered the first pair. So this is the first pair. In that, after the first pair, it will be keep on repeating. So okay, so we have written y of z divided by x of z is equals to alpha 0 plus 1 by beta 1 z to the minus 1 plus 1 upon whatever term is there, we have written it as r1. Okay, So into that, if we have written it's r1, okay, so the same function can be written, okay. So from there, y of z is equals to h of z into x of z. So here h of z is this function alpha naught plus 1 upon beta 1 z inverse plus whatever below terms are there, we have written it as r1z, okay. So that will be multiplied by x of z. So once we will be expanding it, it will be alpha naught x of z plus whatever term this term is there, that will be multiplied by x of z. So that multiplication term we have considered as h1z, okay. So the first expansion will be y of z is equals to alpha naught x of z plus h1 of z into x of z. So we will just draw its structure. So there will be an x of z, okay, and y of z at the output. So the first is alpha naught multiplied by x of z. So whatever alpha naught is there, that will be multiplied by x of z, that will be coming out to be z of y of z, and along with that another term is plus h1z will be multiplied by x of z. So this is x of z. So x of z will be again multiplied by another term that is called h1 of z, and it will be coming out to be added to here. So okay, so up to this part we can realize it as this structure, okay. So x of z, y of z, and this alpha naught will be coming out here, and this will be y of z coming out over here, and it will be added to get the y of z, okay. So this is the first relation, but again we will be taking h1 of z separately, and we will be realizing h1 of z, okay. So h1 of z here is h1 of z is this term, okay, 1 upon beta 1 z inverse plus 1 upon r1 z, okay. And again here r1 z is coming out to be this is not h, this is from the this structure. So up to here, up to this part we have written. So this is your r1 z, 1 upon r1, okay. So 1 upon r1 is there, so this is your r1. So just with another color, okay. So 1 upon something term was there, so this is your r1 term, r1 z is there, okay. So from there we can find this r1 is there, and it will keep on going up to a or alpha n, okay. So once we have uh, replaced these values, so h1 of z, that will be h1 is there, like h of z was there, so it's was given by y of z divided by x of z. Similarly, if it is h1 of z, it will be given by h1 of z is equals to y1 of z divided by x1 of z, okay. So here not x1 of z. Similarly here we can see from there, from the structure. So this is the h1, this is the input, and this is the output, okay. Okay, so this is your y of z, but this is some output, but this output is, suppose y of z is there, y1 of z is the output of this one. So this is the input, and this input is equals to your x of z. So here y1 of z divided by x of z will be given by your h1 of z, and this is given out to be 1 upon beta 1 z inverse plus 1 upon r1 z, okay. And when we will be expanding it after the multiplying, cross multiplying, we will get like y of z is coming out to be this expression, okay. So this coming out to be this expression y of z. From there will be given by r1z, whatever r1z is there, that will be multiplied by this term, okay. So it is r1 multiplied by this term. So it is like a structure called r1z multiplied by another input. So this r1 is there multiplied by another input. So it is like your y1 of z is equals to r1z into x1z, okay. So this structure is now similar to the structure that we have gone through this. So we have realized this one, the first, okay. So after realizing this, we have obtained this one, okay. But this h1 of z, is the function of r1 of z, and then the relation between x of z into y1 of z. After expanding it, we can get like y1 of z will be equals to r1 of z into x1 of z. Okay, so we can replace this term uh, with respect to this representation. We can expand it further. So from there we can see structure x of z, y of z. This is the realization. Then we will be going to realize this term. Okay, we will be going to realize this term. Okay, so here this is your y1 of z, this is x of z, the same term is there. Okay, y1 of z, y1 of z is equals to h1 of z into x of z from the equation. Okay, so but what is the internal to it? So internal to it is this structure. So this one is the structure that is internal to it. So we will be realizing it. So first of all, it will be just we will be realizing it. Okay, so this one. So we need to realize this term y1 of z is equals to r1 of z, that is multiplied to, this is the whole multiplication, this is the bracket complete, that's a large bracket. Inside that there is x of z minus beta 1 z to the power minus 1 into y1 of z is there. So after subtracting x of z minus beta 1 z to the power minus 1 y1 of z, that is completely multiplied by r1 of z. So its realization will be x of z is coming out to be here from here, and we are required to subtract this value x of z with the minus beta z to the power minus 1. So minus beta will be a coefficient multiplied z to the power minus 1. These two will be multiplied by y of z. So y1 of z. So y1 of z is here. So this y1 of z is being multiplied by minus. So it is, this value will be coming out to be minus beta 1 y1 of z. So again, if we are multiplying by this, so this value will be coming out minus beta z to the power minus 1 y1 of z. So this value will be added here. It is being added. So x of z is added. So this value will be your x of z minus beta z to the power minus 1 y1 of z. Okay. So this value is coming out to be here, and this value is coming represented as x1 of z. Okay, so this is being multiplied by r1 of z completely, and that is coming out to be your y1 of z. Okay, so here it is the same written here, r1 of z into this term is there, so this term is represented as x1 of z. Okay. So we can replace these two nodes because this node is also x of z and this is y1 of z. So this complete will be replaced by this term, this complete realization. Okay, so after replacing we will be getting like alpha naught is there coming out to be here, and this h1 of z being replaced by this term. Okay, so this is the term that is realized here below. Okay, so this is the realization of the first alpha naught and beta 1. So in the ladder structure, it was like h of z was alpha naught plus 1 upon beta 1 z to the power minus 1 plus 1 upon, then again alpha 1 plus 1 upon beta 2 z to the power minus 1 and so on. Okay, there are other terms. So this is the first step, you can say. In the first step, we have to realize the first line, first ladder, that is alpha naught, that will be having a constant multiplication from x of z to y of z. Similarly, this term will be giving you out the opposite direction. Okay, in the opposite direction, we have to multiply whatever coefficient is there, that will be minus beta, okay, into z to the power minus 1 in the opposite one. And again, this structure from here, it is similar to realization, whatever the first realizations we have done. Okay, so the first realizations will be there again. So we, once we will be realizing, this will be again repeated, this term x1 of z and y of z. Similarly, it will be represented, so it will be alpha 1 and minus beta 2. Okay, similar to alpha naught and minus beta 1, this r1 of z will be represented like alpha 1 minus beta 2. Okay, and so on, it will be there. So it is like a ladder structure is there. One is this term, second term is there, then again this is the third term, this is the fourth term. Okay, So okay, so this is the first term, this is second one, this is third one, and this is the fourth one, and keep on reducing. And up to what level we will be reducing, that will be depending on the route array. From there we have find out the coefficients. So how many coefficients we have find out, that based on the coefficients we will be keep on expanding the ladder into the downward. Okay, so this is how the ladder structure is being uh, formed. So after combining the three stages, or we can say that this is the infinite number of stages we have connected. Okay, so this is the first pair, the first one, the second one, this is third coefficient, fourth, fifth, sixth, and keep on up to an. Till an is coming out, we will keep on expanding the ladder. The realization will be done. Okay, so based on that we will see on the question. In the question part it will be very easy. So to understand the mathematical expression of the concept, theoretical part was quite difficult, or quite you can say uh, confusing. So we'll see like how it can be done with the help of numericals. Okay, so suppose h of z is given like 2 plus 8 z inverse plus 6 z to the power minus 2. So for this realization, here the coefficients is minus 2 and here again minus 2. Okay, so we need to find out, the first step is we need to find out the coefficients alpha 0, beta 1, alpha 1, beta 2, and keep on. Okay, so to find out that we have to make the route array. Into the route array, the highest power of z is in the numerator and denominator is z to the power minus 2. So in the numerator it is written z to the power minus 2, z to the power minus 2 again. The below powers are z to the power minus 1 and z to the power minus 1 again. Then again 0 power is there, z to the power of 0 is 1. Okay, so 1 1 will be given written here. So in the numerator it is z to the power minus 6, sorry, z to the power minus 2, it is z to the power minus 2. So its coefficient, z to the power minus 2 coefficient is 6, and 1 less than that is z to the power minus 2, z to the power minus 1 will be there. So this is z to the power minus 2, this will be z to the power minus 1, z to the power 0. Okay, so coefficient of z to the power minus 2 is 6, and here z to the power minus 1 is 8 and z to the power 0 is 2. So we have retained the numerator part, numerator coefficients. Similarly in the denominator the coefficients is 12, 8 and 1, 12, 8 and 1. Okay, so now we will be finding these, we have to find out these values. Okay, so this value will be coming out to be this, whatever value is there. So this value is coming out to be 12 multiplied by 8. So it will be 12 multiplied by 8 minus, it will be minus 6 multiplied by 8. Okay, so it will be 6 multiplied by 8 and divided by, it will be divided by this term, that is 12. So it will be divided by 12. So this is how the value of this coming out. So after solving it we can get, it is like 96 minus 48 divided by 12. So it is 48 divided by 12. This is coming out to be 4. Okay, so this is your C, what is n minus 1 value. Okay, so this is C n minus 1. So this is to find out this value. What we need to do is we need to multiply these two value. Okay, we need to multiply these two, and we need to multiply these two and divide it by this value. Okay, so it is so there is a mistake. So the mistake is once we need to find out this value, we need to multiply. I think we have explained it something different. Okay. So it is, we need to multiply these two. Sorry, the previous explanation I have done this. So in 12, we need to find out this coefficient. We need to find out 12 into 2 subtracted by this 2 value. Okay, So 12 into 2, that is 24, minus 6 into 1, that is 6, divided by 12 will be there. So divided by 12 will be there. So that is coming out to be 18 divided by 12. Okay, so this is 3 divided by 2. Okay, so this is the value. So to find out this value, we need to again do whatever is this value, 12 multiplied by another term. Suppose some other terms are there, then that will be multiplied. If there is no other term, that will be considered as 0. 12 multiplied by 0 minus 6 multiplied by 0 divided by 12. Okay, so this is coming out to be 0. So here we need to find out 0, and that will be 0 value. Similarly, to find out this value, we will be multiplying these two, and we will be multiplying these two. Okay, and subtract, divided by 4. So 4 multiplied by 8. So 4 multiplied by 8 minus 12 multiplied by 3 by 2, that is 6 into 3, that is 18 divided by 4. So this is coming out to be 14 divided by 4, that is 7 by 2. Okay, so this is 7 by 2. Similarly, to find out this value, we need to multiply this 4 to this 1. Okay, and we will be multiplying 12 to 0. So 12 into 0, that will be 0. So 4 minus 4 multiplied by 1 is 4 minus 0 divided by 4. So again, it will be coming out to be 1. Similarly, to find out this value, what we need to do is we need to multiply. So we need to multiply these two value, and we need to multiply these two value, and after subtraction, we will be dividing it by 7 by 2. So it is 7 by 2 multiplied by 3 by 2 minus divided by 7 by 2. So it is 21 by 4 minus 4 divided by 7 by 2. So it is 5 by 4 divided by 7 by 2. So this is 5 by 14. Okay, so this 5 by 14 will be coming out. So to find out this value, we need to multiply this to this. Here it is 0, again it is 0, so it is coming out to be 0. To find out this value, these two will be multiplied and subtracted by these two multiplication, that is 0, so again it will be 1 value. Okay, so this is how we should be realizing this coefficients value. So once we have find out the coefficients, the first order coefficient, the column, first column coefficients, so from there we can find alpha 0 is equals to 6 divided by 12. So 6 divided by 12 will be half. Then beta 1, so this will be giving out the alpha 1, alpha 0 value, and dividing these two, that is okay, that is 12 divided by 4, that is coming out to be beta 1. So 12 divided by 4 is equals to 3, beta 1, and then this value, this is alpha 1 value, so it is 4 divided by 7 by 2, so it will be 8 by 7, that is alpha 1 value. And similarly, we will be dividing this one, that will be our beta 2 value. So beta 2 value will be 7 by 2 divided by 5 by 14, so that is coming out to be 49 by 5. And similarly, the next value alpha 2 will be there, so alpha 2 will be 5 by 14 divided by 1, that is 5 by 14. So once we have find out these coefficients, we can expand h of z as 1 by 2, the first term, plus 1 by, what is the coefficient, that is 3 into z to the power minus 1, and this is plus, this should be a plus 1 upon divided by the alpha 1 value 8 by 7 plus 1 upon whatever the coefficient, that is 49 by 5 into z to the power minus 1 plus 1 upon the coefficient value, the alpha 2 value 5 by 14. So this h of z that is given here, so this h of z will be expanded to write in the form of the ladder. So this is the ladder form structure. So once we have written this structure, we can represent it in terms of its structure. So the first coefficient, so input will be there x of z, output will be y of z. Okay. So once we know the input and output and other coefficients, we can see we have to multiply one and this x of z to y of z divided by 1 by 2 coefficient. Okay, alpha naught. Then again it is coming out to be here and adder will be implemented. So this adder will be having a relation from the output. So this will be beta 1. So beta 1 is 3. So if it is 3, then here it will be minus 3. Okay. So here opposite sign will be there. So minus 3 multiplied by z to the minus 1, that will be added. And whatever is coming out to be here, this will be again multiplied by the alpha 1 value. So this is alpha 1 value. This is beta 1. This is alpha 0. Okay. So again in the second one, this is your beta 2 value and this is alpha 2 value. Okay. So this is how the realization should be taking place in the ladder structure form. Okay. I hope you have got the point. So one thing you need to notice this how the multiplication is going to be. So here we need to multiply 12 into 8 minus 6 into 8 divided by 12. To find out the second term, we will be multiplying the 12 into the second term, this term. 12 into 2 minus 6 into 1 divided by 12. Okay, so there is a change in the first explanation. I have changed it. Okay, there was a confusion. Okay, so this is the correct one. Okay, so from there we can find out the coefficients. So once we have found out the coefficient, we can represent the ladder structure form.